Hi everyone, 12.2 and 12.3, very similar lessons. One is on nets and surface area, and then one is finding more so the surface area of Prism. So we're kind of combining these two lessons together here. So let's review some parts of a polyhedra. We have the base. The bases of a prism are parallel and they are congruent. And so this happens to be a pentagonal base. This green figure right here that it's pointing to, that's a pentagonal base. And then all the other faces are called lateral faces. So you see this definition right here for lateral faces. They are faces. They're all the faces that are not the bases. So the bases are parallel. The lateral faces intersect. And they intersect at what's called the lateral edge. So this orange line right here, and there's many lateral edges. This is a lateral edge. This is a lateral edge. It's where two lateral faces intersect. So what we're going to do here is we are going to attempt to make a three-dimensional picture on two-dimensional paper. And so what helps is this dot paper. This is called isometric dot paper. So we're going to sketch a rectangular prism. So kind of think of like a shoebox. A shoebox is a rectangular prism. And we're going to make it 3 units high, 6 units long, and 4 units wide. So start with me here. We're going to kind of start in the middle of our dot paper. And we're first going to go 3 units high. So pick a dot, maybe right about here, and I'm going to go 1, 2, 3 units high. Okay, so that's going to be the height of my rectangular prism. And then it's 6 units long and 4 units wide. So I'm going to go with my 4 units wide right here. 1, 2, 3, 4. And then it's going to be 6 units long, and so I'm going to go 6 this way. 1, 2, 3, 4, 5, 6. So your 3 dimensions, your 3 units, your 6 units, and your 4 units all start at this exact same spot. And then they go 3 units high, 4 units wide, 6 units long. So when you make these, start at the same point, kind of in the middle of your paper, and draw those 3 dimensions. Okay, so one face then is going to be 3 by 4. I kind of went 4 and then 3 high. So this is also going to be 4, 1, 2, 3, 4. And then it's going to be 3 high again right there. Okay. In the same way, this is 6 units long, and then it's up 3 units. It's 3 units high. So 1, 2, 3. And it's starting to look three-dimensional, right? Somewhat. Okay. So now what we're going to do here is the prism is also a 3 by 4 on the back side. So here it's 3 high, so I'm going to go 4 back. 1, 2, 3, 4. And then from this point right here, that's the kind of the bottom of my rectangular prism. So I'm going to go 4 units. 1, 2, 3, 4. The reason why I drew that as a dotted line is because when it's a dotted line, you assume that it's going to be behind the figure. It's there, you just can't see it. And I actually drew this 5 units. Sorry about that. So I'm going to draw 3 high again, and this is behind my prism, so it's assumed to be there, but we can't quite see it. And then we have this 6 in the back, and then this 6. 1, 2, 3, 4, 5, 6. There we have it, everybody. Let me make sure that's 1, 2, 3, 4, 5, 6. Yep. So there is our three-dimensional view of our rectangular prism. Okay, again, the dotted lines are the lines that are the edges that are assuming that they're there. We just can't quite see them looking at our figure. We'll practice this one tomorrow in class. So now what we have a net, and the definition of a net is it's a 2-dimensional figure that can be folded into a 3-dimensional figure. So take a look at this here. It shows a few examples of nets. So here's our tetrahedron. Okay, you can kind of see how it is 3-dimensional. It has 4 sides. They're all congruent triangles. Now if I were to draw the net of this, right now it's 3-dimensional. Watch how it folds into unfolds into 2 dimensions. There's 4 triangles, and they fold back up into 3-dimensional. Okay? If we take a look at our cube, that has 6 sides. So you can kind of see the cube as it spins here. And then you can kind of see how the net is made. So there's 6 sides, and then it folds up just like that. We have it for our octahedron as well. There's 8 triangles, and you could fold those so that it makes 8 congruent triangles. There's the net. A dodecahedron is 12 pentagons. So the flat surface is the net. The polyhedron is the dodecahedron. And then our icosahedron is 20 triangles. And you can see how those 20 triangles, when you kind of unfold them, it makes a 2-dimensional net. So here is the icosahedron, and then it's going to be unfolded. So it's going to be laid out flat. And it's going to look like a net like that. Now it's 2-dimensional. Okay? So that's what a net is. A net is a figure that can be folded into a 3-dimensional figure. So now what we're going to do is we're going to draw the net of the rectangular prism that we drew earlier on this page. So what I'm going to do here, class, is I'm probably going to start with what I would consider the bottom of this box, the bottom of this prism. It's a 6 by 1, 2, 3, 4. This bottom surface is a 6 by 4. So I'm going to put that on my dot paper. That 6 by 4. So right here, oopsies, we're going to go 6 by 4. So here we're going to start kind of in the middle and go 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. So there's going to be 6 faces on this one. There's one of them. Now I'm going to fold down this side. So almost kind of picture this as a hinge, and this whole surface I'm going to fold down so it's kind of here. Okay, I don't know if that makes sense, but I'll explain this more in class. But I'm going to fold this surface down, and the hinge is going to be right there. So that's going to be a... Oh, I'm sorry, everybody. I'm going to do something different. Sorry about that. I already went 6 this way, so what I'm going to do is I'm going to fold down this side right here. Okay, so this is going to be my hinge right here. So that's going to be a 6 by 3. 6 by 3. So 1, 2, 3 by 6. Okay, so I have the bottom on my graph paper, and I have the left side right here on my graph paper, on my dot paper. So now I'm going to fold down the top right here, which is another 6 by 4. I'm going to fold that over. So another 6 by 4. So here is my 6 by 1, 2, 3, 4. And there we have that one. And so now I have the bottom, I have the left side, I have the top. Now this right side back here is another 6 by 3. So I'm going to put that on my dot paper. So one more 6 by 3. 1, 2, 3. Okay, I have 4 of my faces, and a rectangular prism has 6 faces, right? I still have to bring down this side and the back side, which are the same dimensions. It's a 4 by 3. A 4 by 3. So if you want to, you can kind of make the hinge on the 4 side, or you can make the hinge on the 3 side. I'll try to explain that right here. I could go 3. So this is already 4 units right here. And then I'm going to go 3 out this way. 1, 2, 3. 1, 2, 3. And there's my 3 by 4 on both sides. 1, 2, 3. 3, right? Is that what I said? 1, 2, 3. So notice how this distance and this distance are the same, because they're going to fold up, and these 2 edges are going to intersect with this spot and this spot when you fold it. Okay? So if you wanted to, you also could have made it right here. You could have done, here's 3 by 1, 2, 3, 4. You also could have done it that way. So there's a couple different ways that you could draw these nets, but here is one such example. I have successfully drawn a two-dimensional net that was derived from this three-dimensional figure. Okay? So now we get to the big topic here, all of what chapter 12 is about. The biggest thing that you could get from this chapter is surface area. And the surface area of any polyhedron is the sum of the area of each surface. So you find the area of each flat surface and you add them all up together. That's what the sum means. Okay? So what we're going to do here is we're going to find the sum, or we're going to find the surface area of the previous prism. So going here, we have 6 surfaces, so we're going to add up the area of 6 rectangles, because all of these are a rectangle. So easy enough, this one is 6 by 1, 2, 3, 4, 6 by 4, right? And 6 times 4 is 24. And I always like rectangular prisms because there is 2 of each. This one's also a 6 by 4. So there are 2 24 square unit figures. This one right here is a 6 by 3. So a 6 by 3, of course, is 18. And then there are 2 of those. This one's also 6 by 3. And then we have 2 more faces, and those 2 faces are these ones. So it's a 3 by 4 and again a 3 by 4. And our surface area then is the sum of all these areas. 24 plus 24 plus 18 plus 18 plus 12 plus 12. There are 108 square units that go all the way around this figure. Okay, so here's 1 square unit. Here's 2 square units, 3 square units, 4. There's 108 total. And that is what surface area is. Lateral area, a similar concept. It is the sum of the area of the lateral faces. So not counting the bases. That's what lateral area is. We do not count the bases. This one says, draw the net and then find the surface area of the right triangular prism. So we aren't given dot paper, so we're just going to approximate the look of this net. We'll do that quite a few times in this chapter. One thing that we need to know here first, class, is the length of this one. We know this is 5 high, so it's 5 high right here. This is 8, so that means this is 8 and this is 8. We know this is 13 and this is 13, but we don't know this distance or this distance, which are the same. So hopefully you see that this is a right triangle. So if this is 13, now we can do the Pythagorean theorem. 5 squared plus, oopsies, this should have been 13. 5 squared plus x squared equals 13 squared. And then when you do the Pythagorean theorem, you end up getting x to equal 12. This is the 5, 12, 13 right triangle. So I'm going to erase all of my mess here up here, and I'm going to write that this side is 12. All right, so I'm first just going to draw this net by placing this on my net first. It's an 8 by 12. So I'm going to go 8 by 12. So just approximate this with me. This distance is 8. This distance is 12. And then I'm going to, with triangular prisms, I like to put the rectangles on there first, and then the triangular bases I put on at the end. So then I'm going to fold this side down, which is a 5 by 8. So 8 by 5. And then I'm going to fold down this last triangle, or sorry, rectangle, which is a 12 by 13, or sorry, an 8 by 13. 8 this way by 13 this way. So another 8 by 13. So those are my 3 rectangles. And now what I need to do is I need to fold down my triangles. So those are going to kind of be folded out to the side, folded down to the side. So the dimensions of the triangle are 5 by 12 as far as the base and the height. 5 by 12. So I already have 5 right here. So if I go 12 out this way, because notice how this is 12 high, then when I fold this 12 right here is going to match up with this 12 right here. And again, I'm going to have the 12 out this way, and then this hypotenuse right here is the 13. There's our net, everybody. We have 5 surfaces here, and we've written that into a 2-dimensional net for 5 surfaces there. So draw the net and then find the surface area. The surface area is the sum of the area of all the faces. So this face is 8 by 12 because it's a rectangle. This one's 8 times 5 because it's a rectangle. This one's 8 times 13 because it's a rectangle. So 8 times 12 is 96. 8 times 5 is 40. And 8 times 13 is 104. So that's the area of all the rectangles. And now the triangle right here is 1/2 base times height. So 1/2, the base and the height are always perpendicular, so it's 5 times 12. And there are 2 of those triangles with the exact same dimension. Remember, Prism, their bases are congruent. So there's always going to be 2 sides that are the same, at least 2 sides that are the same on every prism. So 1/2, 5 times 12 again. 5 times 12 is 60, and half of 60 is 30. So the surface area is all 5 of these surfaces added up together. 96 plus 40 plus 104 plus 30 plus 30. You add all those together, and that is 300 square units. Okay, last terms of the day. For prisms, we oftentimes see right prisms. That's where the base and the lateral faces are perpendicular. So you see this angle right here would be 90 degrees because it's perpendicular. 90 degrees right here because the lateral faces and the bases are perpendicular. In an oblique prism, we don't see that quite as often, but they do happen. Oblique prisms, the bases and the lateral faces are not perpendicular. So this angle right here is not 90 degrees. So these ones are kind of leaning a little bit. So we'll find the surface area of those as well. Let me know if you have any questions when you get to class tomorrow.